All right, hello students, this is Mr. Holly. We're going to take a look at your Inequalities Packet. Much of what you're going to see in this packet is a review from 6th grade, just a review of symbols, and then we are going to have just a couple of problems that would be at a 7th grade level. So let's just take a look together. Write the correct symbol in the inequality box. That would be greater than is an arrow kind of to the right. Less than would be to the left. Greater than or equal to. So if it is greater than or equal to, we put the line underneath it. That means it could include that value or be more than that value. Less than or equal to looks like this. All right, let's look at some of these contextual situations and see how we would actually write the inequality for them. A school bus can seat at most 48 students. So at most means it can seat 48 students, or it could seat less than that. So could X be equal to 48? Yes. Could X be more than 48? No. Could it be less than 48? Yes. So it could be less than or it could be equal to. I like to ask myself those three questions because that allows me to determine which symbol is the most appropriate. So in many states you must be at least 16 years old to obtain a driver's license. So X is going to be the age you must be to obtain a driver's license. Can I be less than 16? No. Could I be exactly 16? Yes. So I know it's going to be or equal to. Could it be greater than 16? Yes. So greater than or equal to 16, I can get a driver's license. It isn't safe to use a light bulb of more than 100 watts in many light fixtures. So X, can X be less than 100? Yeah, it can. X is the watts in the light fixture. It's got to be less than 100. Could it be equal to 100? Yes, it could. It could. So X is less than or equal to 100. Because it can't be more than 100, that means it could be equal or it could be less. At least 250 parents attended the back to school night. Okay, so is X less than 250? No, because it's at least 250. Is it possibly greater than 250? Yeah, possibly. So X is greater than or equal to 250. Now, this is how we write the expressions. Now let's take a look at graphing. If we look here at graphs, an open circle means that the value is not included. So anytime we graph inequalities, we've basically got we've got four separate ways that we could graph them, but there's two key things we want to focus on. Is the arrow going, so we want to say, is the arrow going left or right? And is the circle open or closed? That's what we're looking at. So in this case, the arrow is going to the right. We know that numbers to the right, that means they are greater than, they are getting bigger. So X must be greater than 2. Now, is the circle open or closed? This circle is open, which means it does not include the value of 2. So we would not say or equal to, we would just say it has to be greater than 2. It cannot be 2 because it is not enclosed. Now we see this second graph down here. Is the arrow going left or right? It is going left, so I know that is the values that are less than 2. It is getting smaller, less than 2. And then, is this circle open or closed? It is closed. A closed circle means it does include this value. So X could be 2, or it could be anything less than 2. You can practice graphing these four different examples right here. Now, on the back, I want you to go through and you're going to just read through each of these terms and you're going to pick what you think would be the most appropriate symbol for them. You can actually color them in if you've got some colored pencils. And then just ask yourself the three questions that I asked earlier. If something is a maximum, could it be less than the maximum? Yes. Could it be equal to the maximum? Yes. Could it be more than the maximum? No. So it could be less than or equal to. You're going to do that for all of these. You can use this key and color them 4 different colors based on which symbol they would be, or you can just write the symbols in, either way. All right. Circle the inequality that matches the situation. So here I have a situation, a word problem like the equations we've solved. You have $10 to spend at the school carnival. Each game, each is a key word here, costs 25 cents. How many games can you play? Let G represent the number of games. So I need to write an expression that describes the amount of money that I'm spending. Okay? Eventually I'm going to write an entire inequality here, but first I just need to think about what's the expression that describes the amount of money I'm spending. Each game costs 25 cents. So am I adding 25 cents to my number of games? Am I subtracting 25 cents to my number of games? Am I dividing my number of games by 25 cents? Or am I multiplying 25 cents times the number of games? Which one of those would come up with the amount of money that I'm spending? Well, if it's 25 cents per game, I'm going to be multiplying. 25 cents times my number of games, that would help me to determine the amount of money that I've spent. Now, it says that you have $10. Can you spend less than $10? Yes. Can you spend exactly $10? Yes. Can you spend more than $10? No. So here's your expression. It has to be less than or equal to $10, and we can come down here and find this option. 25 cents a game is less than or equal to $10. Now let's just solve it. 25 cents per game is less than or equal to $10. I would divide by the coefficient here because I'm multiplying by 25 hundredths. Now if I divide by 25 hundredths, I would find that my number of games is less than or equal to, and just a little number sense here, 25 hundredths is 1/4. So if I'm dividing by 1/4, I'm multiplying by the reciprocal of 1/4, which is 4. So I'm really just multiplying by 4. 10 times 4 is 40. My number of games has to be less than or equal to 40. Could I play 10 games? Yes. Could I play 17 games? Yes. Could I play 50? No. 51? No. 41? No. 25? 250? No. Graph the inequality. Remember that we are graphing G, our number of games played. So let's start here with, let's put 0. Let's use 10 as our scale here. -10, -20. Okay, and I would start at 40. I could play at least 40 games, and I would play any number less than 40. Now, really our domain here is just going to be positive numbers. It wouldn't make sense for us to have, you can't play negative games. But the way we would graph that is just to the left of 40, with 40 having a closed circle. So you play anywhere between 0 and 40 games. Okay, another word problem for us. Caitlin wanted to have her hair braided in multiple braids to cover her head. The beautician charges a flat rate of $4 plus 75 cents a braid. She saved $29 to get braids. How many braids can she get? So as we've done with equations, what do I not know? What am I trying to solve for? It's right here in my question. How many braids can she get? So B is going to represent the number of braids. And if you've been in my classes, I also said I like to put a box around the total amount of money. Sometimes that just helps me because I know that's going to be one expression in my equation or inequality. So I know that whenever I write this inequality, it's going to be 29 as one expression, the total number of amount of money, and she has $29. So can she spend more than 29? No. Can she spend 29? Yes. Can she spend less than 29? Yes. Now, $4 plus 75 cents per braid. That's 75 cents a braid plus $4. And now we'll just go through and solve. If I subtract 4 from each side, 75 cents per braid is less than or equal to 25. divide by 75 cents, which is like 4/3, so that would be 100/3, or I guess you're going to get B is less than or equal to 33.3. Let me make sure that's right. Let me look at the calculator. 25 divided by 75 cents. Yes, 33.3 repeated. So B is less than or equal to 33.3 repeated, or 33 1/3. So this says to write a sentence describing the possible solutions. Well, we've solved it here, but you have to think about it in a real world context, right? Can she get 1/3 of a braid? No. So she can get, Caitlin can get 33 or fewer braids. All right. Now, again, she can't get less than 0, so it's really just going to be between 0 and 33 braids. If I was going to graph this inequality, let's actually just start at 0 on this one and say 5, 10, 15, 20, 25, 30, 35, 40, 45, etc. And it's going to be here at 33 1/3. I'm going to use a closed circle because it is inclusive. She can get 33 1/3 or fewer braids. Now we know that in reality she can only get 33 in a real world context. But the solution to our inequality is 33 1/3. All right, see if we can get one more question in. Yeah, we have plenty of time. Good. The community swimming pool charges a flat rate of $50 for a birthday party, plus $2.50 for each person. There's each again. That tells us, and here's plus again, so this kind of helps us to set up our expression. Deborah can't spend more than $100. More than 100. She cannot spend more than 100. So that means she could spend exactly 100. She could spend less than 100. So what do you think our inequality is going to be? Can't be more, could be equal, could be less. Less than or equal to. All right, here's one expression up here, and here's our other expression, the total of $100. How many friends can she invite? So we're solving for the number of friends. F is going to be our variable. It's going to represent friends. And let's go ahead and write this expression. $2.50 or 2.5 times the number of friends. And it might be important to put the number of friends. $2.50 times the number of friends plus $50 for like the one-time flat rate is less than or equal to $100. So spend a total of 100. Subtract 50 from both sides of my inequality, and 2.5f is less than or equal to 50. If I divide by 2.5, the number of friends is less than or equal to 20. So Deborah can invite up to 20 friends, or no more than 20 friends. And we could make our graph here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. As you notice, I've used different scales on all the graphs. I just need to pick a scale that's going to fit within the allotted space, right? So I know that I can count by 2s and get to 20. It's going to be equal to 20 or less than 20. So I use the closed circle, and I'm going to the left. Now, again, because of the real world context, remember she can invite less than 0. So that could come up, but in this case, we're just going to keep it simple. Less than or equal to 20 guests. All right, guys. Hopefully that helps.